point, you can kind of see it better. Remember, a radius of 0 has no point, it's at the pole. So anything at the pole with a radius of 0 will be your 0, 0. Any angle at the pole with a radius of 0, you don't have a circle. Good? And no, you don't have to rationalize.
So
I think
3 could be 1 over square root of 2.
1 over square root of 2, 1 over radical 2. It's probably my throwback from algebra 2. That's your radical 3 over 2 and your radical 2 over 2. They're instilled in me. Okay? Again, do the sketches. I think the sketches are very helpful. It kind of gives you the location where you are. We talked about this one. We said we can't plot a negative point for number 6. We can't plot a negative, so we send it through the pole, and we plot this one. I think we talked about this in class, right? Because I didn't want you to be confused at night. And again, anything with a 0 radius, if you kind of even plot it on your graph, it's at the origin, it's at the 0.
So, do you have to do, like with this, the first quadrant, all is positive, second quadrant, like, you have to do...
It kind of falls into place with cosine and cosine, so, yeah. Falls into place. It more falls into place on where's my angle located versus my radius, and then I can figure out where my xy point is. It has to be in the same location. So it's kind of a good check. So if like for instance, if I graph this point, and not even like say these are your circles, yes, but say you're here at the 4 and you're here at -3, this point, this xy point has to have an x and a negative y. So when you get here, if this doesn't come out to x negative y, something happens. You know, I'm just saying, just for reference, point of reference, it really makes sense. No, I'm not in a hurry.
Okay.
Good? And then the rectangular to polar, we use your tangent, because it deals with an x and a y, and we use your x squared plus y squared equals radius squared, a squared plus c squared equals c squared, because that deals with your x and y. So those are the two things that we use to go rectangular to polar. And again, if you kind of get a feel for where your point is, you can see where you're going with it. This, when you get here and this becomes negative, where does this point exist? Where would I plot this point? Quadrant 1, right? I'd have to say this is a negative. I'd have to go through the pole. So through the pole would put me where? At pi over 4, right? Would put me at radical 2 pi over 4. Isn't that the same location that I am at 1, 1? So if my 1, 1 is here, I can't possibly be plotted down here, but a negative sends you through the pole. That probably is the hardest concept to get. So we can't plot that negative point.
I don't understand how you got 5 pi over 4 and it's like pi over 4.
Oh, this is your answer.
Oh.
This is your answer. This is just another form of it. I did forgot to ask you guys to do it, but isn't this the same point as this one? Right? I forgot to ask you guys to give me another point, so you're fine. I just said, you know, where would I plot this point? Wouldn't it be the same as that one? And when you get here, -6, 0, isn't it going to be, when you look at it, pi? Isn't that pi there? So sometimes do we even have to go through all the conversion? It's kind of obvious that that would be your pi. So I think if you graph it, it makes far more sense than not sketching it. I didn't ask you guys to make different values. This one was a little bit different. If you left it in radians, that's fine. If you put it in degrees, that's okay.
tell me how you got, oh, you just converted from.
I converted it. You could leave it in radians. It's kind of a weird one in radians, but. Don't worry about 19, because I'm only going to have you work in radians anyway.
For that, like,
Yeah.
on the test.
That won't be on the test.
So I got like 10 theta negative 4 over 3, but like, what would you get after that? Would you put it in the calculator?
Yeah, it's pretty.
Like, you press,
Yeah,
you press, or, like, what would you press? Press 10.
so wait, what did you get?
Yeah, 10 theta equals negative 4 over 3. I didn't know what to do next.
Okay, tell me again, I'm sorry.
10 theta.
10 theta?
Or the
Tangent of theta.
The tangent of theta? Oh,
negative 4.
That's what I got. Yeah.
So like, you got the inverse.
Take the, yeah, if you do it in your calculator, second tan, because we don't have a special angle for this. So those are the other ones we've had special angles for. This one we don't have a special angle for. If you take this and you want to convert this to radians, that's fine. That's what I'm saying. If you want to convert it to radians, that'll work. But if you want to just leave it like that, we don't have a special angle for this. There's not too many that we didn't have special angles for. Most of them are going to be on your special angles. And then this is the last one. And that one too, we didn't have a special angle for that one. But if you want to put that back in the radian, here's your radian measure. It still looks a little bit strange, but you can leave it to me in radians. I'm not too concerned about this one. We do give our answer in radians. So if you're not comfortable with these two, that's okay with me because most of them are in your 30, 60, 45, 45.
So, like, on the test, will they all be special right triangles?
Yeah. Yeah. Because it kind of makes more sense to you, like, where do I find an angle? I know where my angle 56.31 is. Where is my angle in radians? 0.898, 0.983. You're still converting it in your head to get to the degree. So I kind of want you to understand the concept. This one, I think, helps you understand it much better. You know how to rotate those around your circle. This one, how would you rotate that angle around your circle? I mean, you absolutely can. But if you kind of think of it in a degree, it's easier. But convert it to a radian, just so that you can give me your answer in radians. Like, I can't do this. If I asked you for another angle, I can't add pi to something that's in degrees. I have to add pi to something that's in radians. But if you kind of get the concept, yes.
He's a little bit.
Yes, I'm sure he is.
No, I'm
sure
sure
he is.
he's gonna say. I think he would.
Okay, so we have two basic equations. X is equal to r cosine theta and y is equal to r sine theta. Again, the x goes with the cosine, the y goes with the sine. Anytime you have a rectangular equation and we want to convert it to a polar equation, we're just going to use these pieces and replace this. Now this A stands for any number. And we can put any number in, because what would this be an equation of? A circle. So if we wanted to make it like this, and we could make it 9, and your radius would be 3, it would work for any number. So what we're going to do for this guy, and I want to start out with this one, but we can start out with this. You know, if this is your radius 3, what's your polar equation going to be?
3.
Yeah, it's going to be r equals
Oh, r equals
3.
3.
Isn't it going to be r equals 3? Because if radius of 3, it's a circle. Didn't we just do some radius once before I did the little shooty one?
How do you
So,
just decide that?
Well, but you know that, right? From when we were graphing, put r equals 3, r
No, but
equals 5.
I mean,
Oh, we're going to work it all out, but this is what you know it's going to come out to be. You know this is...
she's saying if that was the equation.
It
So,
is.
so like if that was given, x squared plus y squared equals 9, if that was given?
We're going to convert it, but shouldn't it be r equal to 3 when we finish? Or r equal to a?
Okay,
If-
got it.
When we do the conversion, shouldn't we come out with that?
Yeah.
Because that's how we graph it on your polar. R equals 3, R equals 5, R equals 7. All it is a circle. This is an equation of a circle. So, if we take this and we convert this in for x, and we take this and we put this in for y, we get r cosine theta plus y sine r. Equals, I'm just going to put a 9 in here for now. I'll put a 9 in here for now, just so that we have something there. Now, if we take this out, and we want to solve for r, we have to solve for r.
Wait, wouldn't it be square?
Yeah, square. So if we're going to solve for r equals something, and r has to be a number or we're not going to get a circle. To get r by itself, what would I do? What are we going to do?
So I would divide by R.
You can't divide by r, because then we get rid of this, but r would be here, it would be 9 over r. So if I want to get r by itself, what could I do to this? Factor out the r. Okay. Now, what is cosine squared plus sine squared equal to? 1. This is your squared. So let's put a 3 in here. So r equals 3. Okay, so don't we get the same thing? Shouldn't we get the same thing if we're just making a circle?
Yeah.
And technically, if I use a, and I just replace this guy with a, this says any number you put in there will give me a circle with that radius.
Wait.
The original problem said a, but I didn't want to use an a to solve it because I wanted you to see that it comes out like a circle.
No, I have that, but how did you get how did you take the square root?
No square roots. I didn't take a square root. What we did here was we said, you have to give me r equals. So, in this one, they both contain r.
Yeah.
No. The r goes here. The cosine square goes here.
No, but it would be x squared, so x equals r cosine theta, so then all of that would be squared, wouldn't it?
I'm just confused how,
So
because
then you have r squared.
no, it isn't.
Yes, it would. And then it would equal 9. And then my r, you got it. And r squared equals 9. And r equals 3. Yes.
Okay,
Yes.
that's what I was confused about.
Good. Thank you. I'm so thrown off with this board. It just drives me crazy.
I get it. It's Friday.
Oh, no.
Friday morning.
Friday the 13th on top of it.
That's what it is. You're haunted by a ghost, and it's
And
your calculator.
no, this was all happening yesterday. Yesterday, you remember sometimes?
That was like a prequel to today.
Well, you know, sometimes I write on the board and it comes out somewhere else.
Yeah.
This is all day yesterday. Even when I'm doing this today, it's like sliding over on me. I recalibrated this thing like 5 times yesterday. It's driving me crazy.
Technology.
Okay.
Oh,
I want to do, okay, before we do this one, I want to do another one. It's not on your paper. Come on, guys, stay with me. Okay, I want to do this guy first. Now, basic equation says take the y and substitute it, take the x and substitute it. What should this be when you graph this? A parabola. Because on your polar, we can graph other than a circle. So I want to kind of show you that we can graph other than a circle. This is not on your paper, but this is an equation of what? That's going to be an equation of a circle too, or an ellipse. We can graph an ellipse or a circle real easy on your polar. But I want to show you, we can also graph a parabola. So if we plug in these guys, and we get this, we have to solve for r. And remember, r has to be greater than 0. So I can't divide. You never can divide by your variable to get rid of it, right? So I get everybody on one side. It's like having a quadratic, which is what we're going for, a quadratic. So we're going to move everything to one side. And now we can factor out an R. Good with me so far? We're just solving your equation for R.
Wouldn't cosine still be squared?
Cosine is still squared. Yes. So now, when we have your quadratic and we have your two factors, what do we usually do? We have what do we usually do? Set them both equal to 0. And we kind of did this too. Remember when we were solving your trig equations? We did this with your trig equations as well. So I got to get R by itself. So I'm going to subtract sign. Now, this R equals 0, we can never have R equals 0. So we're just going to reject this. So we're going to move this guy to the other side. And we need to solve for R. So we're going to divide everybody by negative cosine squared theta. I got to get R by itself. I'm going to get rid of the negative at the same time. So R is equal to sine of theta. Can't get that in the middle. Over cosine squared theta. Okay. Now, if we graph this, this should be a parabola. So try it on your calculators, because if I try it on mine, it's going to take me forever. So try it on your calculator. Let's see. Let me add that up on the side. We want to say sine of theta. Keep your calculator in radians for this one.
Oh, okay.
I think this one's going to be in radians. I might have to reset your window because we said
No,
it.
it's in degrees.
It's in degrees?
Trust me.
Okay. Did you get a parabola?
Yeah,
Anybody get a parabola? Because I don't think I'll be able to.
I did.
You got a parabola?
Yes, I did.
Okay, good. So what I wanted to do was show you that you can absolutely get other than a circle. So it'll come on here. Or whatever. You guys can get to that. I can get this calculator. All right, so enough for that guy. Just so that you kind of see that it works. This we would see that it's a circle anyway, so I didn't really want to bother with that one. All right, now, real fast, going from polar to rectangular. This one's going to take a little bit more time to do this. Some of them work a little bit differently than others, and you're going to need two things again. You're going to need to know that your, when you do this, that your tangent, you need your tangent, is y over x. Do you have this one on your paper? I don't have this one on mine.
Yeah.
Okay. All right, you're going to need to know, like, your circle, this guy, and anything that deals with an x and a y, and sometimes tangent is helpful. Now, sometimes we can figure this out real easy. If you're going to convert this to a rectangular equation, and r is equal to 2, what does this give me in polar? If I put r equals 2, what do I get? A circle with a radius of 2. So all I have to do is use my circle formula, plug my radius in, because this is one of the things you're going to use, plug my radius in of 2, and there's my rectangular equation. See it?
Yeah.
Okay. Now, sometimes it's not as easy to see. This guy, yeah, but it's not so bad. This guy, I didn't want to do this one, but this is all right. I have different ones than you do, but I don't like this one. So now, if we look at this in polar, where do I find the angle pi over 3? First quadrant. And my angle, if I dropped a triangle, would be what? And I label my sides how? square root of 3, 2, 1. Now if I extended this line all the way down, this is like this line, whatever this line is going to be. I'm going to get a rectangular equation because it's going to sit on this terminating side, and it's going to be a y equals mx plus b type of thing when I'm finished with it, shouldn't it? I should get some kind of y equals mx plus b. So now, I work off my tangent for this guy. Isn't this the same as your tangent? Changing y over changing x? Isn't this the same as your tangent, y over x? That's why we use your tangent as well. We only have two things that work with your x and your y. Your x squared plus y squared equals r squared, and your tangent, which uses y over x. So whenever we're converting to something that has y and x, you're guaranteed to use that. So now, if we take a look at this, what is the tangent of pi over 3? Radical 3 over 1. So therefore, I'm going to take this and make this my slope of my line. So you can plug this in. No intercept. And there's your equation. Okay, make sense out of it first. Most of these are just going to use, here's another one. I don't think you have this one. Mine are all different than yours.
Oh, that's number 4.
Oh, that's the last one?
Yeah.
Okay, so you can put this in your R equal and you can see what this comes out to be. We'll do this in a minute. But if I take this, what is secant in terms of cosine and sine? 1 over cosine. So now, if I want to get this into an equation we know and love, we cross multiply and we say r cosine theta equals 1. What is r cosine theta equal to in our conversion? X. So if I take this and I replace this with x, isn't that a rectangular? A rectangular meaning your xy regular kind of equation. Okay? Let's see if we can squeeze one more in. This one, probably a good one to do. Let's squeeze one more in. Oh, I did have this one. For some reason, mine are all so different than yours. Now, I have no way to replace, oops. Okay, I have no way to replace your cosine of theta unless it says r cosine theta. Because x is equal to r cosine theta. So how can I get an r out there? I can't replace this with x. I need to get to an xy thing.
Okay.
But I can't replace that with x unless I have an r there. So can I multiply this by r? So this is going to give me r squared. So what is this guy? This guy is now x. Good so far? How do I get rid of my r squared? What is the other piece of information that uses x and y? So can I replace r squared with x squared plus y squared? And looks like we got a circle coming up with a translated center. Good? Okay. Work on these homework problems. Today was a crazy day, I'm sorry. Oh, why didn't you just come up and get them? Wait, where are they? Hang on. Let me get them first.